Hello guys, welcome back to the course. In this video, we are going to learn step by step on how to calculate infectious disease transmissions using SIR model. As you guys can see, we're going to utilize three equations. So if you want to learn more about these equations, just click on this link and it will take you to this website. Alright, so yeah, you might want to read this explanation. It's going to help you to understand this concept. Okay, so now let's go to our whiteboard. So we're going to use this data for our case study. Okay, so now let's assume that the total populations is 1,000 and the initial susceptible is 900, right? So there are 900 people who have the potentials to be infected by this disease. And the initial infectious is 100, so there have been 100 people who get infected. The transmission rate or the infection rate is 0.3, which is pretty low in my opinion, and the recovery rate is 0.1 or 10%. Okay, so now we're going to use these three equations to do the calculations. Okay, so let's get started, guys. So the first thing that we're going to do is to calculate the amount of people who get infected. So we're going to use the second equations, di over dt, and it's going to be equals to beta multiplied by I multiplied by S divided by N. So in this case, beta represents the transmission rate, which is 0.3, and you're going to multiply that by I. So I represents the initial infectious, so in this case it's 100, and you're going to multiply that by S. In this case, S represents the initial susceptible, which is 900, and you're going to divide that by N, which represents the total population. So in this case, the total population is 1,000. And don't forget, you're going to subtract these with gamma multiplied by I. So it is going to be the recovery rate, 0.1 multiplied by the initial infectious, which is 100. Don't worry guys, if you're too lazy to do the calculations, we're going to use Google Calculator. So we have 0.3 multiplied by 100 multiplied by 900. So this is what you got, 27,000. Don't forget, we're going to divide that with 1,000, which is the total populations. So you got 27, and we're going to subtract that by 0.1 multiplied by 100, right? Okay, so this is what we got. So 17 people get infected. All right, if you might be wondering what is the total amount of people who get infected, as you guys can see, initially there have been 100 people who get infected, and there are 17 new people who get infected. So we're just going to add 17 to 100. So in total we have 117 people who get infected. All right, okay, so let me write it down, infected, like this. Okay, so the next thing that we're going to do is to calculate the people who have been recovered from this disease, right? So we're going to use the third equation. So it's going to be dr over dt, like this. So it's going to be gamma, which is the recovery rate. In this case, it's 0.1 multiplied by I, which is the initial infectious, so it's 100. So you're going to get 10 people recovered, right? So there are 10 people who have recovered from this disease. Okay, so what's next? We're going to use the first equations to calculate the new susceptible. So it's going to be ds over dt and it's going to be negative beta, so negative 0.3. Remember that beta represents the transmission rate. And next we're going to multiply that by I, which represents the initial infectious, so multiply that with 100. And you're also going to multiply that by S, which is the initial susceptible, so it's going to be 900. And don't forget, we're going to divide that by n, which is total populations. So in this case, it's 1000. Okay, so if you want to do the calculations using a calculator, feel free to do it, guys, because I'm too lazy to do it manually, to be honest with you. So we have negative 0.3 multiplied by 900 multiplied by 100, and this is what you got, negative 27,000. Don't forget, we're going to divide that by 1000 because that's the total population, so you got negative 27. And if you remember, guys, the initial susceptible is 900, right? So by definition, susceptible basically means that there are 900 people who have not been infected by this disease, but they have potentials to get infected, right? So we're just going to subtract 900 with 27. So we're going to get 873 people, all right? You might be wondering, like, what does it mean? Okay, so initially we have 900 people who have the potentials to get infected, but they have not been infected yet. But we got 70 new people who get infected and 10 people who have just recovered from this disease, right? So you're going to subtract 900 with 17, and you're going to subtract it with 10. So it's going to be 873 people who have not been infected yet, but still have the potentials to get infected in the future. Okay, so we're done with this. The last thing that we're going to do here is to calculate the basic reproductions number, or R0. Okay, so this is the formula for R0, guys. So it's going to be beta multiplied by S, which represents the initial susceptible, and you're going to divide that by gamma, which is the recovery rate, right? Okay, so in this case, the beta is 0.3, that's the transmission rate, and you're going to multiply that by the initial susceptible, which is 900 in this case, and you're going to divide that by gamma, which is 0.1, right? So we're going to use a calculator again because I'm kind of lazy to do the calculations manually. So we have 0.3 multiplied by 900, and this is what you got, 270, and you're going to divide that by 0.1, right? Okay, guys, so this is what we got, 2,700. So let's write it down here, 2,700, right? Okay, so the R0, the basic reproductions number for this disease, is 2,700. And you might be wondering, what does it mean? Okay, so this basically means on average, its infectious individual will lead to 2,700 new infections when introduced to a completely susceptible populations. So if R0 is greater than 1, it indicates there is a potential for this disease to spread. And if R0 is less than 1, the disease is going to die out, all right? It's going to disappear. In this case, as you guys can see, the R0, or the basic reproductions number, is very high. It is 2,700. So it is very likely for this disease to spread, all right? Okay, guys, I think that's it. That's all you need to know. Make sure that you understand this concept because we're going to implement this concept to our project. Okay, so I'll see you guys in the next video. Bye. Hello, guys. I'm sorry, I missed something here. So let's go to these websites, guys. Don't worry, I'm going to provide you with the link. So this is Infectious. This is an epidemic calculator using SIR model. So actually, this is the same exact thing like what we did here. So you'll be able to play around with these variables. So let's say for the total population, it's going to be 1,000. Just plug in like a random number, guys. Do your own experiment. So let's say the susceptible is 97%, and there are 2% of the populations that get infected, and 1% has recovered. And if you scroll down, this is the graph, right? So you'll be able to visualize what's going on using this graph. So the yellow line represents the susceptible, the dark blue line represents the recovered, and the red line represents the infected. people. Okay, so yeah, it's going to help you to understand what's really going on here, right? Okay, so I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.